Part 1. The universe can be broadly divided into the following stages. Planetary system. A system consisting of a star, sun, and the planets, moons, asteroids, and comets that orbit it. A system consisting of a star, sun, planets, moons, asteroids, and comets that orbit it. Our solar system is a representative example. Galaxy. A vast celestial system consisting of hundreds of billions of stars, interstellar matter, gas, and dust. It has various shapes: spiral, elliptical, irregular, etc. There are countless galaxies in the universe, including our Milky Way. Galaxy group/cluster. A system where tens to thousands of galaxies are bound together by gravity. Galaxy groups are relatively small collections of galaxies, while galaxy clusters are much larger. Our galaxy belongs to the local group. Supercluster. A large structure formed by the gathering of numerous galaxy clusters and galaxy groups. It is one of the largest gravitationally bound structures in the universe. The local group, which our galaxy belongs to, is located on the outskirts of the Virgo supercluster. Large-scale structure. A vast structure where superclusters gather and connect like a network. It consists of long chains of galaxies called filaments and vast empty spaces called voids. It is the largest known structure in the universe to date. Observable universe. The region that includes all celestial bodies and space that can be observed with current technology. It is estimated to be a sphere with a radius of approximately 46.5 billion light-years centered on Earth. However, this does not represent the size of the entire universe. Entire universe refers to all of space-time, matter, and energy, including the observable universe. The size and shape of the entire universe are not yet accurately known. These stages help us understand the structure of the universe and demonstrate its vastness and complexity. The grand opening of the universe. From the Big Bang to 1.8 billion years, 13.8 billion years ago. The beginning of time and space. The Big Bang. Breaking the silence of nothingness, everything began from an unimaginably hot and dense point. The Big Bang was not just an explosion, but the moment when time and space themselves began to expand, the birth of the universe. The very early universe was unimaginably hot, and all matter and energy were clumped together. Immediately after the Big Bang, the universe expanded rapidly and cooled down. The early universe was so hot that even light could not travel freely. Fundamental particles such as quarks and gluons existed, but the state was not yet conducive to forming atoms. It was a chaotic period, much like a violently boiling soup. Approximately 13.8 billion years ago, 13.799962 billion years ago. The plasma universe and the birth of fundamental particles. As the universe expanded and the temperature dropped, quarks began to combine to form protons and neutrons. However, the universe was still in a plasma state filled with free electrons. Light could not pass through and was trapped, colliding with these electrons. Approximately 13.799962 billion years ago, 13.799992 billion years ago, nuclear fusion and the first elements. As the temperature of the universe continued to decrease, protons and neutrons collided to create heavier atomic nuclei. The elements mainly formed during this period were hydrogen and helium. This is an important period when the most basic materials that make up the universe today were created. It was like a process where new metal is melted and formed in a giant furnace. Approximately 13.79992 billion years ago, 13.79962 billion years ago. The birth of the cosmic microwave background radiation, the universe becomes transparent. About 380,000 years after the Big Bang, the temperature of the universe had cooled down enough for electrons to be captured by atomic nuclei, forming neutral atoms. As the freely moving electrons disappeared, light was no longer obstructed and could travel freely through space. This light is what we can observe today as the cosmic microwave background radiation, CMB. The CMB is the hot afterglow of the early universe and strong evidence of the Big Bang. It is like the first cry of a newborn baby, light containing the traces of the universe's birth. Approximately 13.79962 billion years ago, 13 billion years ago, the Dark Ages and the beginning of gravity. After the emission of the cosmic microwave background radiation, the universe temporarily plunged into darkness because stars and galaxies had not yet formed. However, gravity was still at work during this period. Slightly denser regions began to attract surrounding matter, and this became the seed for the formation of stars and galaxies. It is like the invisible force preparing to create stars under a quiet night sky. Approximately 13 billion years ago, 12 billion years ago, the birth of the first stars and galaxies. Due to the action of gravity, denser regions began to gather more and more matter and clump together. As these clumps contracted, their internal temperature rose, and finally, nuclear fusion reactions occurred, giving birth to the first stars that emitted light on their own. These stars began to form early galaxies. This period is a revolutionary moment when light began to turn on again in the universe. It is like small lights appearing one by one in the darkness to form a vast city. The universe 12 billion years ago was much smaller and hotter than it is now, and early galaxies were actively forming stars. The universe at this time is the early form of the magnificent and complex universe we see today. In this way, the universe from the Big Bang to 12 billion years ago went through a violent process of birth and growth. The Big Bang, which was like a small spark, expanded and cooled down. Atoms were formed from basic particles, and finally, the first stars and galaxies were born through the force of gravity. This grand history of the universe will continue to unfold.